So in this lecture, we're going to be talking about how economists essentially build models. And we're really going to focus on, let's do this here, sorry. I'm going to do view. Sorry, I'll just do it this way. Sorry, just to get us more space here. What I want to focus on is the idea that economists have, which is that free trade benefits all. Sorry, I'm not that bad of a handwriter, but I'm doing this with a digital pen here. Okay, so let's put it over here. So free trade benefits all. If you had to have one of a very few takeaways from this course, it would be that line. This is some 350-year-old belief that emerges in about the 1700s. Before that, we had this notion with a type of economist called a mercantilist. And the mercantilists were, as the term sort of implies, they were merchants, businessmen. And their belief was that the only way you make an economy strong is by basically selling stuff, a lot of stuff, to the rest of the world, meaning exporting a lot of things, selling finished goods, final products, but on the other hand, not buying a lot of finished goods from other countries, not importing a lot of things. And so many of the countries that were doing this became quite protectionist, meaning they want to protect their internal industries. Now, this isn't too different from even kind of what we see around us today. And this isn't being overly political, right? I mean, try to find a politician who says that they're for free trade. Most politicians, right, have to get voted into office. And they're not going to get voted into office if what they're saying is that your job may end up overseas. But what we are going to learn in this chapter is that while it may look good to say that you're protecting American jobs or whatever your line is, that it ultimately doesn't work to the advantage of the country. That you should let countries focus on what they do well and then trade for the things that the other things that they need to survive and thrive. And that if you allow countries to specialize in what they produce, trade for the other things, everybody will get to consume more than if they just produced it all themselves. And so that's what we mean by benefits all. That everyone within the country will combined be able to consume more than anyone would have been able on their own. Okay, so what did we look at? In the previous chapter, we looked at this idea that economics is this science of scarcity. It's a study of how people allocate their limited resources to meet all these wants and needs. And so scarcity becomes the important theme. Scarcity is this idea that somehow there has to be a logic, there has to be a science to how do we allocate our scarce resources to the best things that we could have. So, the way that this continues on here is that we can understand that amount of the sacrifice. We can measure it if we think back to those key concepts in economics. That important way to measure that would be with what's called the opportunity cost. We're going to be using those concepts here in this chapter. And so what we're going to do here in this chapter is we're going to start off by looking at this idea of how do you build a model. So this will be kind of a review if you've taken any natural science course in your college career or even in high school career. As well, we'll just look at how these models, once they are built, what kind of results they give us, right? That they give us typically quantifiable results, which we can understand as part of the positive analysis, and that typically that's then handled by others to do what's called the normative analysis, to pass points of view. And then we use that to build our first model in this course, with our first model being this production possibilities frontier, or as I'll simplify it, what's typically called the PPF. Now, if you're a person that likes to learn online and you don't like me lecturing and you like, well, then you're probably not even hearing this lecture right now. But if you are that kind of person and you like to Google things and try to find things on your own, you may see it referred to as the PPC, Production Possibilities Curve. Just know that they are the same thing. And from that production possibilities frontier, we can understand two things that can happen from that: economic growth, as well as specialization in trade. Okay, so I'm going to skip these kinds of questions here. So how do we build a model, right? What does that scientific method consist of? Well, if you look at these 4 steps, again, you should be getting some bad memories of high school at this point, or even worse memories of an intro college course in the sciences. Because essentially what scientists do is they develop a hypothesis, then they build a model, which is how they got to that hypothesis, and then they test that hypothesis with available data, and then they make adjustments as needed. Now, this is an important slide. Yes, it's an important slide because it really highlights the fact that economists like to think of themselves as different from sociologists or political scientists, others in the field. But let's not overdo it here. This is just me talking about this here. Let's not overdo and think that economists are scientists. What I'm saying here is they try to act like economists. And yes, many of my colleagues, at other institutions, spend a great deal of their time just developing models and collecting data to test those hypotheses. There's also a fairly large number of economists out there that do some quite innovative work that don't build scientific models, which is not something you would find in the natural and physical sciences, right? The idea that you would find a chemist who doesn't build models would be highly unusual. And what I'm saying to you is that it's not that unusual if you find an economist doing it. Now, from these models, once they're built, what you see is that economists tend to make either positive statements or normative statements. That for the positive statements, these are statements of what is the case. It's a statement that can be tested and validated. You could say something like income in the United States has been increasing, right? Because it's either increasing, decreasing, or staying the same. But I would argue that you could come up with others here. I could say that unemployment is 6%. I could say I am pregnant. I could say I am 6 feet tall. Right? Because each of these are 3 things that are testable and essentially are either true or false. Right? And that would be a good way to kind of understand these positive statements as well. It's a statement that is either true or false with no in-between. You can't be kind of pregnant. You either are or you're not. You can't be, well, I guess you can be almost 6 feet tall, which is, every time I talk to someone who's 5'11", they seem to always say that they're 6 feet when I am 6 feet. But when I meet someone who's clearly shorter than me, and they say, yeah, I'm almost 6 feet tall, it really rubs me the wrong way. Not because I'm trying to highlight the fact that I'm 6 feet tall and that person's not. Rather, well, how often do I ask someone how tall they are? But if I'm asking someone how tall they are, I don't really want to get a normative statement. I'm going to want to get a positive statement. I am 5'11", right? That would be a positive statement. If the person says I am almost 6 feet tall, what I'm reading it as, it is false that you're 6 feet tall, because you aren't. Now, a normative statement is a statement of what ought to be. So you'll see lines used of like should, ought to be, they're basically opinion statements. So that would be something like me saying, anyone that lives in Hawaii should know how to swim. I don't know how to swim, right? And people say that's really bad, but the best thing I can say to anyone is, I didn't grow up here. I grew up in the Midwest, where you wouldn't have large bodies of water. Well, we left the Great Lakes, but you don't have large bodies of water to have to worry about. So, right, an opinion, what ought to be, should be, you can't test that. You can't validate that. It's just a statement that has no verifiable facts behind it. So what you tend to see is that when economists really focus on building models, they really tend to focus on this. So if you're the type of economist that builds models, you're going to focus on the creation of positive statements. On the other hand, if you're an economist who doesn't build models, then those type of economists tend to build normative statements. Okay, so here you get some examples here. We could just do this one. This is really simple. Rich people should be taxed more. That would be a normative statement, the key idea here being should. More taxes on the rich will increase tax revenues. You could understand that as being incorporated into a model, so that would be a positive statement, because it would be testable. If I raise the taxes on the rich, now you'd have to somehow define the rich. So that becomes a little bit normative, but outside of that word rich, let's just replace that. Like if this were an exam, this would be a really bad thing here. If I made this income of $50,000, more taxes on those who earn an income of $50,000 or more will increase tax revenues. We could understand that as being constructed as a testable statement. So here we've got a normative statement. Here we've got a positive statement. Everyone should donate to charity. Should. I hit something on the side here. Sorry. It's not going to let me write anymore. Normative statement. Government intervention in markets is bad. That would be a normative statement. Why is it normative? Here it is normative because we don't really know what bad is. And this would be a positive statement. We could make that testable and whatnot into something else. Okay. So what is a model? Well, it's an abstraction from reality. It's a simplified version that we use to, in a shorthand way, understand the complexity of the world. it simplifies the world, and what it does is it creates a set of dependent and independent variables, where I can try to understand whether there's correlation between the variables, meaning they both move up, they both move down, or if there's, beyond correlation, if there's any causation, is one of the variables causing the other variable to change in some specified way. Within these models, one of the things that you see then, because it is a simplification, because it is an abstraction from reality, economists love to use the assumption of ceteris paribus, meaning all other things being equal. So this is a central assumption within model building. And what this means is that we keep everything else constant. So what you can understand here then existing is that, right, if we wanted to look at a variable here, you should say something like, oh, yeah, that has a horrible color. Let's just pick black. Okay, that's just really bad. Let's say I want to understand intelligence. Where does intelligence come from? Typically what we would say is that it's a function of, so here's my fancy S, that it's a function of genetics, it's a function of schooling, it's a function of, prenatal health, and a bunch of other things, right? That's how we would understand a model, right? That there's some variable on the left-hand side of the equation that's influenced by the variables on the right-hand side of the equation. And the idea is that if I want to do this part, if I want to understand how one of these variables is affecting intelligence, like for instance, if I want to understand how does genetics affect intelligence, then what I need to do is I need to build a model where I'm going to keep these other variables here, schooling, prenatal health, and all these other things. I need to hold all of these things constant and allow then just genetic changes to cause changes in intelligence. That will at least tell me that there's correlation between those variables. And so what we can see here, extending this further, that what we can do is we can look at factors that are endogenous, and we can also look at factors that are exogenous. And what we essentially do when we're building a model is we have to make choices. We can't take everything into account. And so because we can't take everything into account, what we find is that, do you see how in that previous slide I left it at ... That basically we would call it sort of an error term, or basically there's a lot of stuff that the model isn't explaining. There's other things happening that are exogenous that can control the whole thing. So for instance, we could talk about like COVID and a global pandemic being an outside factor that could also affect intelligence. Not only because it can affect all of these things, but it can also affect how all these things interact with each other, right? So you can have exogenous variables that are not accounted for in the model, and then you have your endogenous factors, the things that are controlled for inside the model. That would be each of the individual variables that are on the right-hand side. The more you make the models, the variables endogenous, then the more realistic the model is becoming. Or basically, the model will have better explanatory power. And this then becomes the art of being a good scientist or even just a good economist. How good are you at deciding what variables to include and or exclude? Sometimes you exclude a variable just because you can't even find a good way to measure it. Or you have to use what would be called a shadow variable, a variable that mimics or allows us to see indirectly the other variable, right? Just like a shadow could tell you the form of my body, right? My general shape, my general height, and whatnot. I wouldn't see like the color of my skin or anything like that, right? All shadows are black. But, right, in this case, as a professional, I have to be able to decide what variables do I think are excluded versus what variables are included in this model. And so we can kind of see this here. So that all leads us to our very first economic model. So this model dates back to, essentially we can date it back to probably Adam Smith and some of the first economists, modern economists out there. So what the Production Possibilities Frontier does, the PPF does, is it tries to model how resources, if they're used efficiently, what kind of outputs could we get? Now, how does that look? Let's take the USA. We've got about 330 million people. We have lumber. We have water. We have land. And we have technology. What is technology? Technology is the way that I combine these things. I can't write anymore. I will figure it out here. I'm racing it now. So what technology does is it's basically the process by which I combine resources together. And so what we have in the USA is all these natural resources. We have the people that we have technology that combines these things all together. And what we do is we look at a society that is going to produce two goods. So the classic example that we actually see comes back from the 1950s. And it came down to this idea, right? We had just finished fighting World War II, and we were entering the Cold War, where we were going to be fighting the Soviet Union. And the choice presented to us was, well, we're going to take all of our people, all of our land and resources, and we were going to produce stuff for the people, things like butter, or we were going to produce warlike things to be able to fight the Soviet Union. And the idea of why they were saying that was because, of course, any person would just say, yeah, we want lots of stuff for our people. Or they would say, yes, we want a very strong defense. But you have to understand that there is a trade-off in those two. I could have a lot of butter, but very few guns. So this would be quantity of guns. And this would be quantity of butter. Or I could have a lot of guns, but very few butter. Or I could have something that mixes the two. And if we kept plotting out all of these points, we could eventually connect the dots. And what we would have is kind of an outer bound line of what is a possibility of what we could produce, given all these choices of the things that we could produce. Now, we could produce less than that, or we could produce right on the line, but we're going to see here that I can't produce beyond the line. So that's what we're going to be doing here with the next few slides here, is we're going to be building this Production Possibilities Frontier model. where the technology is fixed, the resources are fixed, and the society is only producing two goods. In this case, we could just say guns or butter, but you can make it any two goods that you want. But this is the key idea. The key idea is that there is a trade-off. Producing more of one good leads to less of another if I am on the frontier. And we can measure that trade-off the opportunity cost. Let's kind of keep it simple here. The opportunity cost is that number, the amount of that trade-off, what we're sacrificing. And so what we can see here is that, for instance, if I go from point A to point C, then I'm getting 30 less pizzas, but I'm gaining 90 wings, right, from A to C. That is my opportunity cost, right? The opportunity cost of one pizza is 3 wings. That's my trade-off. I give up one pizza and I get 3 more wings, right? Which is a 30 to 90 ratio, which is a 1 to 3 ratio. Look at this. This is a straight line PPF. Let's look at it from C to D. I give up 20 pizzas, so I get 20 fewer pizzas, and I gained 60 wings, which is also a 1 pizza to 3 wing ratio. And we could do D to B. D to B would be 50 pizzas for 150 wings, which is a 1 to 3 ratio. W standing for wings, P standing for pizza. Look at that. 1P to 3W, 1P to 3W, 1P to 3W. This line here is a straight line. The slope of the PPF is the opportunity cost. It is the trade-off. I'm giving up 1 pizza for 3 wings, 1 pizza for 3 wings, 1 pizza for 3 wings. Or alternatively, 1W is a third of a pizza. Right? I could just divide each side by 3. And so all of the efficient points are on the frontier. So if we drew out this PPF here, we put our wings, quantity of wings here, quantity of pizza here. Do my straight line. Then what we'd be saying is that the points inside the frontier are inefficient. The points on the line are efficient. and the points outside the line are impossible. How do we know that these are inefficient? Because I could be at this point inside the frontier, and I could get more pizzas without giving up wings. Or I could get more wings without giving up pizza. Or I could get more of both. So essentially, when we say that something is efficient, it requires a trade-off. Right? On the frontier, I have to give up something of one good to get the other. Which would mean that something is inefficient if no trade-off is required. Meaning it's possible to get more of one good without giving up the other, or it's possible to get more of both goods. These points are impossible because it would require more resources or a better technology than you actually have. Now, most PPFs are not shaped as a straight line. Instead, most PPFs are drawn as having increasing opportunity costs, which would mean that most PPFs, we keep that as wings and we keep this as pizza, quantity of pizzas, quantity of wings, is that most PPFs are drawn like this, where they're curved. So it doesn't change any of the concepts. If I'm on the line, I'm efficient. If I'm below the line, I'm inefficient. If I'm beyond the line, it's impossible. None of those things change. But now what we're seeing is that as I move from left to right along the PPF, the slope of the line is getting steeper. And what is the slope of the PPF? The slope is the opportunity cost, which is why this is increasing opportunity cost here. Because essentially the slope is getting steeper. The question would be, why is that the case? Why, in reality, are most PPFs shaped like this? Well, the best story I can tell is, or the best way to describe this quite simply, is that, as the first bullet point highlights here, not all resources are good at producing certain things. So, for instance, I would not do well at being a preschool teacher, right? I'm an okay professor, but to be a preschool teacher, I'd have to, I don't know, I'm actually okay changing diapers and whatnot. I'm good at that kind of stuff, but, handling the internal drama of kids, I can handle my own kids, but it gets harder when they're not my kids. I don't have that skill set. My wife is really good at that kind of thing. I don't know why I'm bad at it, and I don't know why my wife is good at it. It's just each of us was built a little bit differently, such that that is the way that we are. On the other hand, I don't think my wife would do very well, for instance, teaching a college classroom. It's good. She thinks a lot. She waits a lot to think a lot before she starts talking. But you can imagine, for instance, in a college classroom, you might get quite annoyed or impatient waiting for the person to say something. Again, it doesn't mean that she's a bad person. It just means she was built differently, just as I was built differently. Which means, right, what happens when you get closer to the extremes is that if this was quantity of college lectures and we were at the extreme, that would mean that someone like my wife would have to be a college lecturer, right? Have to be a professor, which wouldn't be very good because she'd be giving up a lot of the thing that she does do, which is she's in finance. So her job in finance, she'd have to give up her entire book of business just to teach maybe one class that she wouldn't even be very good at. So, right, why would you want to give up that kind of incredibly steep slope, right? Why would you want to have that huge trade-off for that person unless you really, really, really needed them? You probably wouldn't. And so that's what we can see here in this kind of picture that's drawn here, is that at these extremes, what's happening is that we are still efficient, but the trade-off is huge. Why? Because certain resources become mismatched or inappropriate to building the other thing. Right? You give up a lot of the other thing. A lot just to get a little bit. Or you give up a lot just to get a little bit. And so this is the reality, right? Because we do have lots of different resources out in the world. Yes, I could use lumber to build a car, but it wouldn't do all the same things that metal can do. But right, if I'm really operating at the extreme, yeah, sure, I guess I can build some cars out of wood. Now, we can change the PPF if other things are changing, such as we get more resources or we get better technology. And what that would do is it's going to shift the PPF. So I don't know why everyone seems to be anti-immigrant labor. I mean, I get it, but I mean, in the sense of I get it because people want to like keep their wages high and maybe they just don't like, you know, housing becoming too crowded or whatnot. I mean, people have their reasons for whatever their beliefs are. But as I see it, in a world where, in a society where, you know, people are making choices not to have as big of families, the consequence is that we're not getting a lot more additional people, which would mean for us is that more people means that I shift out the PPF. Right? This is supposed to be kind of equal, not to be. I wasn't trying to favor one good over the other. Let's just say this parallel shift outward. More people means I can make more stuff. Or in this case here, looks like I have, I don't know, maybe a, how do you spell mozzarella? I don't know. Let's say I get a technology that allows me to make more mozzarella. Well, that's going to aid me in the production of pizzas, but it's not going to really do anything for me for wings. Or if I come up with a technology that makes it possible to have more chickens, well, then it's going to just shift out differentially my wings production. So we could have a differential shift, or we could have a parallel shift. And here we see this parallel shift. You tend to see that with, I don't know, this is essentially why everyone's getting all excited and whatnot about AI. The idea is that artificial intelligence can take over lots of different industries and essentially create this entire outward shift of the PPF curve. I mean, that's what investors and whatnot are all banking on. Now, let's go through each of these practice what you knows just because it seems relevant here. So true or false, that point A represents the amount of cars and bicycles that will be sold. That is false. What a PPF does is it tells us only what can be produced with our given technology and resources. It doesn't say anything about what will actually be sold or purchased by others. True or false, A movement along the curve from point A to C shows us the opportunity cost of producing more bicycles. Yes, that is true. What would that be? Right? It would be whatever that number is, right? Let's say that this was 100, and that was 75. And this is going from, let's just make my life easy here, from 3 bicycles to 2 bicycles. Then 1 bicycle would have a trade-off of 25 cars. And that would be the opportunity cost of a bicycle is 25 cars. I added these numbers in. There's no logic to why I said these numbers. And if we have high unemployment, then the curve shifts in. That is not true. Unemployment is basically an unused resource, which basically means that the frontier stays the same because it's still drawn, for instance, as if we have 330 million people. But if someone is capable of working and doesn't look for work, then it just means that we're going to become inefficient. It doesn't actually change the frontier. What would change the frontier would be something like this. If COVID kills 100,000 people, then that will shift in my PPF because now I've got less people. So again, the line is drawn. The PPF is drawn with the resources that we have. And we basically just have that reduction. An improved process for manufacturing cars is produced. Society will be able to make both more cars and more bicycles. Well, that better technology means, again, what is manufacturing? The manufacturing would be where my resources are combined. And as I combine those resources, I'm able to produce more vehicles and more cars and more bicycles, shifting out the frontier. If, on the other hand, I pass a law that says AI can't be used, then that could shift in my PPF. Sorry, there's like these little buttons on this pen, and I just hit it. And that would shift in my PPF. If I pass a law that says the technology can't be used. And taking that further then, suppose there's high unemployment, what will happen? Then unemployment would mean that we'd be at a point inside the PPF. So again, it would look like this. This is quantity of good 1. And this would be quantity of good 2. And that I would be inside that curve. Okay. I'm just going to pause here for a second. So now with this idea of the production possibilities frontier, we can imagine that different countries have different production possibilities frontiers. So you could imagine a situation where you have one country that's able to produce a lot of ice, let's say, as opposed to bread. And that in another country they can make a lot of bread, but not a lot of ice. And so what this would create is a situation where these two countries needing both bread and ice could create a situation where this country would focus on making ice, this country would focus on making bread, And when we say that they're going to focus on something, what we're saying is that they will specialize and then trade for the other thing. So for instance, if we look at the university setting, I teach only economics. I don't teach human health, right? I mean, I'm the kind of guy that, once you start talking about body parts and whatnot, I'm the kind of guy that like starts to snicker or laugh. And yes, I understand that's really immature, and someone that's 47 years of age shouldn't be like that. But essentially, I have no business being in a, human body, human health class, right? I'm not that guy. I focus on economics, and I'm pretty good at it, right? Whereas the people that teach those kinds of classes, like human health and whatnot, they have a different demeanor. They have a different outlook in this world. They're just different than me. Shouldn't they focus on what they're good at? I'll focus on what I'm good at. And then, in some sense, a student needs to take both kinds of classes. So, right, they will, in some sense, right, we'll come up with some exchange between those two countries, or in this case, these two kinds of professors. In this case here, we've got basketball, right? We don't tend to see basketball players also becoming, right, or actually the more famous example, like someone like Michael Jordan, who was really good at basketball, but not as good at baseball. And he probably did the best of anyone at doing two different kinds of sports like that. But he didn't even do them that well, because it's really hard to pull off that kind of being good at multiple sports. So let's start to build this here. Okay, so we still have our same assumptions that we had with the production possibilities frontier, which was that our technology is fixed. We have a certain fixed set of resources. We're only producing two goods, but now what we're saying is that we have different abilities in the production of those two goods, which again essentially means that we have two existing production possibilities frontiers. What it's going to create are two kinds of advantages, what we're going to understand as the absolute advantage and a comparative advantage. What an absolute advantage just says is that I can make a larger quantity. Right? You're just bigger. Right? So we would imagine a big country like the United States, a big country like China, a big country like Russia can produce a lot of stuff. They could have the absolute advantage in a lot of things. But for the most part, countries aren't going to have a comparative advantage in everything. And what the comparative advantage means, and what's more important for economists, is that they have the lowest opportunity cost. They can make their goods the cheapest. So if they have a lower opportunity cost, basically it means that they should specialize in the thing that they're really good at. Countries should specialize where they have a comparative advantage. And that's what we see right here. Because producers have a different ability to produce goods, they're going to specialize and then produce the thing, focus on producing the thing that they're good at, and then trade for the other good. So let's go with Gwen and Blake. It's not a choice of names. Wait, is that like I think these are famous people, aren't these? Isn't that Gwen, like Gwen Stefani, and isn't she married to someone named Blake, maybe? I'm not going to go down that rabbit hole of that kind of thing, but anyway, let's just go with Gwen and Blake. So, essentially we would have Gwen, and we would have Blake, and they're going to have their wings and their pizza, their wings and their pizza, quantity of wings, and whatnot. And what we're going to see that for daily production, Gwen can make 60 pizzas or can make 120 wings. And that Blake can make 24 pizzas or 72 wings. So then here's our questions. Who has the absolute advantage on pizzas? Who can make the most pizzas? So if we're looking at this here, Gwen has the absolute advantage on pizza. Gwen also has the absolute advantage on wings. Can make more wings than Blake. Then the question comes, should the same person produce both pizza and wings? The answer is no. They should produce according to their comparative advantage. So that's what we need to calculate here. 60 pizzas for 120 wings is a 1p to 2w opportunity cost for Gwen. 24 pizzas to 72 wings, which is 1p to 3w. So now, if you're trying to look at the comparative advantage, you can basically say who makes, on pizzas first, who makes pizzas the cheapest? It costs Gwen 2 wings to make a pizza. It costs Blake 3 wings to make a pizza. So Gwen can make pizzas the cheapest. It only costs her 2 wings. Now, to get your answer for wings, what you need to do is now I need to divide each side by the other good. So now it's going to be 1/2 of a pizza to 1 wing, right? So I just divided each side now by 120 rather than dividing each side by 60. And over here, I would have 0.33, or I guess I should say a third, just to keep it kind of consistent. A third of a pizza for a wing for Blake, if I just divide each side by 3. So now who makes wings the cheapest? 1 wing costs 1/2 of a pizza, 1 wing costs 1/3 of a pizza, which is less. So our answer here is going to be Blake. And that's how we're going to see our comparative advantage. And so now we can kind of look at this a little bit more formally here. Here you can see these extremes that you graphed out, 60 and 120 versus 24 and 72. And again, we can take this out here. And again, you can say the 1p to 2w, 1p to 3w, because right, I'm just doing the trade-offs along this. So I'm giving up 6 to get 18. Or a 1-to-3 ratio. Here I'm giving up 20 to gain 40, which is a 1-to-2 ratio. And we can kind of see this here as well. That then what you would do is that if they didn't trade, they would have to both be producing, they'd have to produce both goods because they need both pizzas and wings to apparently to survive. And so the production which matched their consumption if they didn't trade. But what's key is that if they do decide to trade, production doesn't have to equal consumption. I'll repeat that again. If they do decide to trade, then production doesn't need to equal consumption. They can produce what they're good at producing, which is that Gwen had the comparative advantage in pizza, so she'll make just pizza. Blake was good at wings, so he's going to make just wings. And then they're going to trade at some specified ratio to get the other good. And that would allow them to consume outside of their production frontier. They can each consume outside of their PPF. Notice when we put that point outside the PPF, we just said it was impossible to produce beyond that point. They still have that the case. They still can't produce beyond the frontier, but now they can consume beyond the frontier. And that's what we see right here, that they can now consume outside of their frontier for each of them. The question would be is, what is that ratio that they're going to trade for, right? We identified how we know what each of them are going to focus on. They're going to focus on the thing where they have the comparative advantage. What we need to do is we need to find that term of trade. That term of trade is going to exist somewhere between each of their opportunity costs. And the reason why it has to exist between the two of those points is because if, for instance, it was 1 to 1, right, which is clearly outside of the middle between the two. If it was 1 to 1, then a producer would say basically, why would I engage in that trade willingly? Why would I give up one of these goods to just get one of the other when I could do it myself, right? And have something where I get two of the other good every time I produce less of some other good. So we have to be between the two production possibility frontier opportunity costs, and that will allow us to, for both countries, to mutually benefit from the trade. So we have to be between the two ratios. And what you need to do, this is probably the hardest part of this chapter here, what you need to get into the habit of is you need to get into the habit of being able to understand how to convert the ratios back and forth. By that I mean, if we go back to this ratio here, let me just kind of formally write it out here for one more time here. Okay, so let's say we've got these ratios as they are. 60 pizzas to 120 wings. What I want you to get into the habit of is to be able to describe each good's opportunity cost, meaning what I'm going to do is divide first each side by 60 so that I've got 1p to 2w. But then what I'm also going to do is divide each side by 120. And that for Gwen, these are my two opportunity costs. And then here for Blake, divide each side by 24. And then divide each side by 72. And now you can see what I'm comparing. I'm comparing this to this. Those are my terms of trade. So 1p must trade between 2w and 3w. If it doesn't trade between those two ratios, then each country will decide to do it themselves. And on the other hand, one W must trade between 1/3 of a P and 1/2 of a P. If it doesn't, then each country will decide to do it themselves. Okay, so we can understand this as well as happening within households. And certainly in my household. I make the school lunch in the morning. I drive my oldest son to school. My wife, she double checks homework and she makes sure the kids are bathed. I don't know. Why that's the case. I don't want to say that we're just perpetuating gender norms here or whatnot. I mean, I'm actually fine dressing the kids if my wife wanted me to do that, and I'm happy changing diapers and doing all those things. It's just that each of us just, we started out doing something and we just keep doing it because we just keep getting better at doing it. And let's not worry about this. I don't think you really need to worry about this too much here. So where does that take us for this lecture then? That we then need to separate out when we think of this production possibilities frontier. We need to think about, and we constantly face this kind of decision. Are we going to be a society that focuses on producing consumer goods, or are we going to focus on producing capital goods? Capital goods are useful, but the problem is that it delays the enjoyment from it because the capital good is just used to produce more consumer goods, but only in the future, not right away. Consumer goods are obviously nice because you get to consume things right away and you get happiness out of them right away. And so then there's this general theory that if you decide to focus more on producing capital goods, that your country will grow even more, meaning the PPF will shift out even further. Otherwise, if you focus on making consumer goods, your PPF will not shift out as much because you're not developing the capital, the technology that will help your country grow. And that's what you're kind of seeing here, that the more capital goods that are produced, the more the production possibilities frontier will shift out in the long run. And then finally, what you can think of yourself as doing right now is that you're investing in a capital good, that capital good being known as human capital, that it's an investment in yourself, right? That's going to theoretically pay off in more consumption in the future. So you're delaying some present consumption right now to be able to consume more in the future. Oh God, what, 25 years ago? I did this really interesting research project. Well, I think it's interesting. But what I was looking at were people that were like new settlers on the frontier and being like the first arrivers in a new piece of farming land. The idea was that those farmers would be more productive because they had more site-specific knowledge about how crops grow and whatnot in a certain community. And the idea was that that human capital was valuable. And the question would be is how much can you understand it? How do you look at it today? Many of you probably remember that discussion of someone in high school saying something like a high school graduate earns, $100,000 more over their lifetime. And you heard that number and you're like, man, I'm going to go to college then. And what would that mean for us here, right, is that would be that measurement of the value of that human capital. Okay, so what did we do in this chapter? We basically understood or graphed, we plotted out what a model is for the very first time, and then we built our first model, the production possibilities frontier. And what that production possibility frontier does for us is it allows us to create a scenario where we can understand that key statement of, let's see here, let's get my mouse working here. The key statement again of free trade benefits all. And that statement is represented by a PPF where I have, let's say, two goods, quantity of X and quantity of Y. And it allows me to consume outside of my PPF.